The telephoto lens, it will always see the sunlit side of the whole side of the earth as it rotates about its axis every 24 hours and as it rotates about the sun every 365 days. That will give us a new perspective of the overview effect of what this home is that we call planet Earth and what it looks like on a daily basis every 2 hours.
This is Robert Hurt and Tim Pyle, two multimedia artists at IPAC Caltech.
Yes, the planet.
They take scientific discoveries that look something like this and turn them into something like this. Scientists recently discovered the TRAPPIST-1 system, a dwarf star with 7 exhilarating exoplanets, some of which could even harbor life.
Normally, when we have 1, 2, maybe there were 3 exoplanets we had to illustrate at once. All of a sudden, this thing came through and there were 7, and they were all Earth-sized, potentially terrestrial, potentially able to bear water on the surface. So this really became a whole different level of project that we're trying to go at.
But all they have to work with is this, a graph showing light intensity coming from TRAPPIST-1. Each dip represents a planet passing in front of the dwarf star, and from that data, scientists can calculate everything from the size of the planet to the mass, density, and orbital periods.
We still have only relatively little data about these, but what we try to do always is create one plausible model that at least does not go against what we know to be true about the system at a given stage.
It's a fine balance, creating something imaginative while ensuring the renderings are scientifically accurate.
One of the pieces of art I did for the TRAPPIST result was a surface view of planet TRAPPIST-1F. The planet was determined that it was likely tidally locked, so one side always faced the star, one side didn't. So it was also determined that it was fairly low density, which meant a greater probability that there could be water on the surface as opposed to just dry rock. We determined that the best plausible look we should illustrate was that the side facing the star would be liquid water and the side facing away would be ice. And then at the terminator line, it would transition from ice into water, which is pretty cool. So we thought it would be great to do a surface view of that planet and put our camera perspective right there on that terminator. And then beyond that, we can see this persistent twilight. Because tidally locked, the star is never, you're never going to see it like rising and setting, from the surface view. So it's just always looks like sunset because the star is right there on the horizon.
There's a lot of sort of technical iteration of trying to get the structures and features we want to exist on the surface. But then there's this whole extra layer of just tweaking and tweaking and tweaking until it perceptually feels right. And that's where we go, I think, way past the science inputs, and that's just, instinct.
That's one of the debates that we've had, right? Which is how much should we push our artwork toward photoreal versus diagrammatic art? I think we tend to move a little more photoreal because there's some emotion in that. Like we can imagine that's a real place out there.